Why does this bridge stand solid for 100 years? But that small wall in your house develops cracks in just 6 months? And how can water, something you can scoop with your hands, destroy concrete dams? It all comes down to one powerful subject: engineering mechanics. But here's where most students get confused. Is it just about forces or only about motion? Why are there rigid bodies, deformable bodies, and fluids? Engineering mechanics is the science that studies how forces affect objects, whether they move, change shape, or flow like water. It applies principles from classical physics, especially the laws of Isaac Newton, to predict motion, deformation, and flow. Structures fail due to incorrect force balance, excessive deformation, or uncontrolled fluid pressure. Mechanics lets us predict this before we build. Civil, mechanical, structural, and aerospace engineers all rely on these calculations to ensure safety and precision. Let's break it down into its 3 pillars: rigid body, deformable body, and fluid mechanics. First, rigid body mechanics. We assume the body does not change shape under load like a steel crane arm during analysis. Statics studies bodies at rest, keeping things stable. Dynamics studies bodies in motion, dividing further into kinematics and kinetics. Kinematics focuses on motion itself, velocity and acceleration, while kinetics looks at the actual forces causing that motion. Next, deformable bodies or solid mechanics. Here, deformation matters. Bodies change shape under stress like concrete bending. Key concepts are stress and strain. Hooke's law tells us how materials behave before they reach their limits. Third, fluid mechanics. This covers anything that flows: water, air, oil, or even wet concrete slurry on a site. By studying pressure and flow, we understand why the base of a dam must be thicker to resist deep water pressure. In summary, rigid means no shape change. Deformable means it bends. Fluids flow. Every structure goes through these stages. For real-world design, follow codes like IS 456 and IS 800 to ensure structural integrity and compliance. Remember RDF. First, assume rigid balance, then check for deformation, and finally, look for fluid behavior. A concrete slab behaves like a fluid when poured, but a deformable solid once it sets. One structure, multiple branches of mechanics. Ignoring these principles leads to serviceability failures, legal cases, and safety risks. Engineering is the art of prediction. From lab tests to site inspections, mechanics is what we verify to guarantee the structures of tomorrow. Master these pillars and you don't just build, you build with confidence. Mechanics is the language of safety. Follow for more engineering deep dives. See you in the next one.